Alright, welcome everyone to our next video in this sequence or series of videos talking about code constructs. So in this one we're going to wrap it up and we're going to take a look at loops and then switches and the corresponding jump tables. There's things called jump tables and we'll take a look at examples of both. So with loops, that's very common in programming and you're likely going to see not only in the rest of the exercises throughout the course but the examples that we look at and in a lot of the programs that you look at as well, they're going to have loops in it. There's a variety of loops that we'll talk about or that you may see, the while loop, the for loop, the do while loop. For the most part here we're going to focus on the for loop and the while loop. Now when it comes to analyzing, there are ways to tell the difference between the two, and that you can, when you look at it in IDA, you look at the disassembly, compilers will oftentimes implement those in unique ways. But for the most part, it's not all that important. The important thing here is that you can identify a loop, and we'll see how to do that in a moment. And more importantly, you understand what that loop is providing the program. For example, loops are primarily there to iterate. So if that's the case, then how many iterations do we get? What about a while loop? You know, oftentimes while loops the condition will be maybe a function call. You know, let's say that it's waiting for a network connection or for your computer to connect to the network, right? We can understand then what that loop is providing and sometimes in the conditions that it's waiting for. So those are the important things that we're trying to be able to identify when looking at that disassembly. So we'll first look at a for loop, and remember that for loops have these main components to that. They have an initialization, they have a comparison, they execute the instructions, and then there's an increment or a decrement. And a reason why a lot of programmers like for loops or that for loops are situated for certain types of logic is that everything's declared within the for loop itself. So in our class folder, you can see again here is the static folder under code inside of the course materials folder. We have a C file called loops and the resulting compiled version as well. I'll just go ahead and open that up. Okay, and we'll get IDA here open in just a minute, so I'm going to kind of squish this over to the side. But what you can see here with this program is that I have a main method. Okay, so there's our int main. Inside of main then, I have size underscore ti and then a for loop. And pretty straightforward for loop, and then I is equal to 0, so there's our initialization. Here is our condition, so I is less than 10. And then finally we have I++. Okay, so that's increment or decrement. In this case it's obviously increment. Inside of the loop we have the execution of statements. And so very simple, we're just printing off the value of I as we iterate through the loop. Now how we're going to see this in IDA is that we're going to see this variable is initialized, this condition is checked, we're going to execute the statements, and then you'll have the increment and decrement. And you'll see that very clearly here in IDA Pro in the disassembly. Okay, we'll look at this one first, and then we'll come back, we'll talk about while loops, and we'll take a look at this function call, do while loop, where we'll look at a while loop. So I'm going to go ahead and I'm going to open loops.exe. We'll give IDA here just a second to get loaded. Move things around just a bit. Okay, there we go. So everything's loaded up. Okay, now normally the first clue, your first indication that there's a loop in this program with IDA is this flow, this control flow. And you can see that we have a flow that's coming from one of these blocks back around to a previous block. So that's usually your number one indication that there's some sort of a loop that you're dealing with. Again, whether that's a for, whether that's a while loop, maybe it's a do while, it's a little less relevant or important. What's more so is that we're understanding the functionality. If we switched views and we went to list view, you would still see here over to the left this control flow, this arrow backwards indicating this loop. Okay, so even in this view, you still have insight into the fact that there is a loop in this code, that we get to this location here, this instruction here, this jump, and this jump takes us backwards. Backwards in the sense that these addresses go from higher to lower, and it goes from a higher address back to a lower. Okay. So what about the actual implementation here? Right, so what we're looking at then is you're seeing this is essentially our initialization. Okay, this loop is I equals 0, and we can see here that we're moving into this local stack variable 0, EBP plus var4. So this is being initialized with 0, so we know that's actually our counter variable. And if we hit the N key, that allows us to rename it, and I'm just going to go ahead and rename that I. Okay, next thing that happens is we go to this location here. and you can see that there is a comparison. EBP plus I, so there's I is being compared to 0A hex. And if it helps us, we can right-click on that and convert that to base 10 and see that that's 10. Right, so there's the comparison that's going to occur for this condition. Now, that's just doing the comparison. This, JNB, is our conditional jump instruction. And you can see that the result of this comparison, this is how we're going to determine whether or not we jump to this location. Right, we're going to jump, if this is true, we're going to jump to this location. Otherwise, we're not going to jump, and we're going to execute these instructions. So we have to remember what JNB is. And if you go back and take a look at the slides that we've been using, I have pasted in here a list of those comparisons. And so you can see that JNB falls under the unsigned column. So JNB branches if V left is greater than or equal to V right. Lost my place for a second. Okay, so if it's greater than or equal to 10, so if the result of this comparison, if the result means that it was greater than, I is greater than or equal to 10, then we jump. Where does that jump take us? It takes us right here. This is not a part of the loop. Even though it looks like it is because of the way this arrow wraps around it, it isn't. This is actually the end of the function. This is the end of main. This call is the call to the do while loop, which we see right here. And then we have the XOR VAX, the function epilogue, and then return. We're returning from main. So that's actually not it. So if we take this jump, that means we're jumping over the loop. We're done with the loop. The loop is broke, right? So greater than or equal to 10. The condition that we're looking for is that I is less than 10, right? So we don't take the jump if I is less than 10, which is the actual condition in the original source code, and this is entering into the loop body right here. This is our loop body. Okay, and you can see we're moving I into ECX, we're pushing ECX, we're pushing the offset, which is our format specifier, we're calling printf for cleaning up the stack, and then we're done. And that's the inside of our loop. That's the instructions that correspond to this printf right here. Okay, then once this is done, it jumps to this block. And what this block is doing is this is actually incrementing our counter. So we see that we move I into EAX, we add 1 to EAX, and then we move EAX back into I, or EBP plus I. Once we're done, this jumps back to this location, goes to this location right here. Sorry. And now we do the comparison again, right? As long as I is less than 10, we don't jump and break the loop. We enter into the loop body, execute the loop code, increment the counter, and then loop back around. Okay, and so that's how you identify and also try to understand how a loop is working. So that with this information, you could get pretty accurately in recreating, just from this disassembly, and recreating that loop in maybe C or C++ or some higher level language. Okay, so let's take a look now. Go back to our slides. We'll take a look at the while loop. Let's see, while loops, very common. They're very common in malware as well, specifically because it's oftentimes waiting for a condition. With a for loop, we normally have a set number of iterations that we're looking for, normally. With a while loop, we're normally waiting for a condition to be met, so we don't necessarily know how many iterations they're going to have, or we're going to have, or need. So in this case, you can see maybe waiting for a socket connection, or if the program is waiting to receive a packet, it might just be implemented in a while loop. Okay, we go back to IDA. We can see here, we're going to call this function next, and that's going to have a simple while loop inside of it. Before we go there, I almost forgot. One thing that I wanted to point out here is that this instruction, JNB, okay, if we did not have the original source here, the use of JNB, okay, and let's go back real quick. JNB, unsigned, JGE, JNL is signed. So we know by looking at that code, looking at that disassembly, and only by looking at the instruction that was used, that it's treating, its comparison is for an unsigned integer, right? And so there's oftentimes little things like that. For example, the type of instruction that was used, this gives us insight into maybe the type of data that was used in the program. For example, we know that I is unsigned because it's using JNB. Goodness, I'm sorry about that. Because JNB is an instruction used with unsigned values. Okay, so little things like that can help gain insight. And in this case, that really has no significant impact on our analysis, but maybe in a different program it would, because maybe that same counter variable would be used later on. So just something I wanted to point out. Okay, back to the while loop. So here we have do while. Okay, very simple, x equals 99. While x is greater than 0, we're going to print, and then we're going to decrement. In this case, the condition is, implement this a little bit closer to kind of our traditional for loop. So the decrement is being done inside of the loop itself. Okay, to get to that function, we can see this is the end of our main function. Here's that call to that subroutine. So we can go ahead and double click that, and here is that loop. Okay, again, we can see this arrow coming back around, so we can identify that this is a loop here, a loop structure. We can see right before this comparison block, var4, we move 63 hex into var4. Okay, we can convert that to base 10. We can see that's 99. So this being done immediately before these comparisons, pretty good indication that this is going to be used as our condition or our counter variable. So in this case, I'll make this x. Okay, here's our comparison. EBP plus x is being compared with 0, and it's jump if less than or equal to this location. So if the result of that, x is less than or equal to, we jump to this location. This is the end of the function, right? Here's our epilogue, rebase the stack, pop EBP, and then return. So if we don't take the jump, then we enter this loop. So the jump is less than or equal to, the condition is while x is greater than 0, right? And that's exactly what we have here. And so you have to pay attention to that, because sometimes you look at this and at first glance you say, okay, my condition must be less than or equal to, because that's the conditional jump here. But that's not the case. The actual condition to enter into the body of that while loop is x is greater than 0. It's less than or equal to, we take the jump, we don't go into the body of the loop, and the loop is done. Okay. From there, enter the loop. You can see things are getting set up for that call to printf, very similar to what we saw at the last example. You can also see that here, because I'm doing the decrement inside of that loop, it's not a separate code block. It's being done right here. Okay, x is moved into ECX, x is subtracted by 1, ECX is moved back into x, and then we jump back to the comparison. Okay, and there's our basic loop structure again. Okay, so slightly different than this. This right here typically means you've got a for loop. And again, not that it matters. If I asked you, and you will in an exercise or one of the labs, take a binary, take this assembly night and try to rebuild the source. I care not so much that you identified whether it's a for or a while, that you got the conditions right, the number of iterations right. That's really the important thing. All right, perfect. Let's see. Next thing, last thing we'll talk about. Switches and jump tables. Okay, so what you'll see is that switches will be, depending on the size of the switch, the number of cases that are included in that switch, you'll see that they're either going to be implemented in one of two ways. The simplest, which means that there are the fewest number of actual cases, would be with a bunch of comparisons and then jumps. Comparison and then a jump. Comparison and then a jump. All these being conditional jumps. And you can see this in that screenshot here. Another way is when you have a large switch, a switch that has a lot of case statements. What you'll find then is that in order to make them more effective, the compiler will generate what it calls a jump table. And we'll take a look at both of those examples here right now. Okay, sorry for the glitch there. I just wanted to get some things set up here before we jump back into it. So we'll take a look at the switch. So I've already got that open, and I already went ahead and opened up IDA. And here we go, here's IDA. Okay, so here you can see in the source code, I'll get back to the beginning in IDA as well. Here we can see in the source, just kind of similar to what I did in the last example, is I put one example in the main function and then I put another inside of a different function. I just do that so that they're not all together in one graph view, so that it's hopefully a little less confusing. So the first one is a relatively small switch. You can see I've got 3 cases, and what we're going to see is an example of that first kind of if style switch statement. We'll see how that's implemented. Comparisons and jumps. Okay. The second, you can see there's just a couple more cases, but it's large enough to generate a switch table, or a jump table, sorry. And we'll take a look at how that looks in assembly so that Again, these are pretty big, these are pretty obvious structures when looking at them in IDA, especially in graph view. And for the most part, you should be able to identify them relatively easy. Not to say that you're going to exactly be able to figure out how they work. That's usually not too bad either, though. Okay, so let's take a look at the first one. Here's our program, and I'm just going to go ahead just because this is a little more real estate. I'm going to make this bigger while we talk about it. Okay, so this is the first one. Okay, and this is your if style, and that here we have we're kind of getting set up. If you look at that original function, you can see we're going to switch on the value of I. I is an integer variable. I initialize it to 0. I then optionally set the value. Well, I don't optionally. You have to set the value if you ran this program using scanf. Okay, not a big deal here. 0 is getting moved into var 8. Right, so that's our int I being initialized. You can see there's a push, enter a value, call puts. Okay, so that's just printing the value, cleaning up the stack when we're done. Now we're loading the effective address of EBP plus I into EAX. Right, so that's putting the address for I on the stack into EAX. We push EAX, we push the offset, we call scanf. Right, and we're doing that because when you call scanf, scanf needs an address. We use the address operator on I. Okay, and that's what we're using LEA. LEA loads into the destination an address, regardless of the syntax. You have to use the syntax with square brackets. That's moving an address there. Okay, so that's how you're seeing the address getting loaded into a register and then pushed onto the stack for the call to scanf. Okay, then once we're done, I is moved into ECX. ECX is moved into var4. And now var4 is used for all these comparisons. And what we're doing here, var4, is the value of I. And so I'm just going to rename this. I guess I'll just call it switch for now. Okay, so we look at our first case. We can see it's case 0. Okay, this switch is going to be compared to 0. Remember the comparison, it's v left, so this first operand, and we're going to subtract from it v right. Right? So we jump if 0. If the subtraction, if they're both the same, the result is 0 and the 0 flag is set. And that's how this conditional jump operates. So it'll jump if the 0 flag is set, if switch is equal to 0. Okay, where are we jumping? We can highlight that address. Going to that address, you can see we're pushing the offset for you entered 0. Okay, and that's of course what each of these cases is doing. You entered 0, you entered 1, you entered 2. And I just did that simply to more easily identify the code block that represents that case. Once we're done, we jump to what location? Here, which is the end of the function. Right? We're done with the switch statement, and that'd be true of this control structure. Once we're done with this case, we break. We're done with the switch. We'll call the function large switch, which is what we're going to do right here. Okay, if that's not the case, if we don't jump, then we go here. And now we compare, switch to 1. Okay, that's our next case, 1. Okay, jump if 0 to this location. We're going to jump here, and it is you entered 1. Right, so switch is equal to 1. Comparison will result in a 0. 0 flag will be set. Conditional jump, jump if 0. Okay, go here. Once we're done, back to this place. Okay, if that's not the case, we go here. Do the same exact thing, except now we're doing it with 2. If it's 0 flag is set, so switches has a value of 2, we go here and print. If not, we go here and we jump. Right, and this last little jump here means that we didn't enter any of these cases. Okay, so you can see, and that's what the slide was trying to display here, or show you, is that this is going to be a comparison and then a jump if 0, another comparison and then a jump if 0, another comparison, jump if 0. This is the list view, text view. We just looked at it in the graph view. Okay, so let's go look at the other one now. So this one is a slightly larger switch where we're going to actually generate, the compiler actually generated a jump table. Okay, so here's that call. Sub 401000. You can double click that, and you can see looks quite a bit different. And this is kind of the telltale sign in IDA that you're dealing with a jump table, because you can see this one block of instructions right here, these 2 instructions, and then all these potential locations that could go to. All these locations you can see similar to the last one. You entered 0, 1, 2, 3, and then a default case, which I just put in there. I guess I don't care what you put in. Okay, and we can see that by looking at what's being printed. Right, here's case 0, and IDA, in my case, IDA even annotates that for you. You entered 0, you entered 1, you entered 2, you entered 3, and I guess I don't care. So what happens? How is this one any different than the last? Well, it's how we get to these cases. It's how the execution of this program is going to determine how to get there. In that previous example, if you entered 2, then you'd have to go through several comparisons before you finally got to that case statement, right? The jump table eliminates all of that. So let's take a look. Similar to the last, you can see with this example, I just hard code I equal to 3. Here we can see 3 is being moved into var 8, so we know that's I. Okay, I is moved into EAX, EAX is moved into var 4. Okay, so this is our, I'll just call this switch 2, since I've already used the value switch. Right, switch 2 now is being compared to 3. Okay, this is where things get different, these next few instructions. So we compare this value to 3. Right, so compare v left minus v right. Okay, JA, what does JA do? Well, if you don't know, you have to be able to go and consult a table or something like this, look at some documentation. JA, unsigned, branches if v left is greater than v right. So let's go back and look. Okay, well, switch 2. If switch 2 is greater than 3, we're going to jump to this location. And what is that? It prints off, I guess you don't care. I guess I don't care what you put in. That, in the original code, is the default case. Right? So if none of the cases match, that's our default. We're going to do that. None of them match, we're going to do that for sure. Okay? And that's what that's comparison. That's comparing right now. It's saying, okay, I know the cases, and if none of them match, I'm just going to jump you right to the default case. Right? Okay, if that's not the case, so we've now determined that switch is 0, 1, 2, or 3. Right? 0, 1, 2, or 3. Those are the cases that we have. We've now determined that. Right? Greater than. It jumps if it's greater than. So we know that 0, or switch 2 is now 0, 1, 2, or 3. Okay, so now it has to determine which case to go. Which one of these to go into. And the really cool thing about this is that what we're going to do now, it's all done right here. So switch 2 is moved into ECX, and then you see there's this jump offset ECX times 4. Right, so what is this? Well, this is the actual jump table. So you see this offset, ds colon offset. If we double click that, this takes us to the actual jump table. And what you can think of a jump table, think of it as an array with whose elements are addresses. So this array has, in this case, because there's 4 cases, it has 4 addresses, 4 locations that represent those case statements. They're D words, so each location is 4 bytes long. So what this is doing then is it's saying, okay, ECX times 4, compute that address and jump to that location. Okay, so ECX is going to be 0, 1, 2, or 3. Right? So if it's 0, ECX, so 0 times 4 is 0. If we go to this jump table, this is the 0 offset. If we double click that, that takes us to this location, which is case 1. You entered 0, or I'm sorry, case 0. You entered 0. Okay, what about case 1? All right, so ECX is now 1. So 1 times 4 is 4. We'll go to our jump table. This is 0. This is a D word, so it's 4 bytes. So if we add 4 bytes to that, we're at the second element. Double click, and here we go. You entered 1. Right, so we're at for case 1. It just continues now. So if ECX is 2, goodness, sorry about that. ECX is 2. 2 times 4 is 8. If we go to our jump table, this is 0, this is offset 4, this is offset 8. Okay, and now we can see that jumped us right here. Case 2. Okay, and then finally 4. So, or I'm sorry, 3. 3 times 4 is 12, or C in hex. 0, 4, 8, C, 12, C in hex, 12 in base 10. And that's our last case. Right? So now instead of doing any comparisons, we have one comparison, in this case to determine if it's greater than any of the cases, so it takes you to the default. Otherwise, it computes it and jumps there. So it's it's quite a bit more efficient. Right? So there's the jump table. All right, that's our kind of our run through here of control structures, and we'll look at some more throughout the course, but those are the primary ones that we're going to see and definitely encounter during some of the labs and the exercises. So take a look at this code. Again, I encourage you to compile it, make some modifications of your own, look at it at night, and make sure that this stuff is making sense. And if it's not, let me know so that we can either practice together or I can provide some more demos or something to help get you there. So with that, I'll stop the video and I'll talk to you guys in the next one. Thanks.